everybody, and greetings from Korea or Thailand, wherever I'm actually on my sales and commissioning tour. I am pleased to have this opportunity, even when I'm not with this nice gentleman together on the tour in the East Coast. I am here to give at least this small video introduction of KIMA process control. So I will start immediately. Thomas, again, thank you for this opportunity. And yeah, let us start. Now, KIMA process control is providing Cement 4.0. We call it Cement 4.0 because we supply Industrial 4.0 exclusively to the cement industry. And here we have intelligent sensor systems and high sophisticated software, control systems, expert systems. So we do since nearly 25 years nothing else than Cement 4.0. Expert systems for kilns and for mills need sufficient instrumentation. And one of our core products here is SmartFill. SmartFill is an electronic 360 degrees impact sound analysis system for ball mills. It is installed on the ball mill chamber itself and listens into chamber 1 and chamber 2 with special sensors from structure-borne sound. Over 900 of these systems are installed globally, so we are seriously providing here the cutting-edge technology. The raw signals from this structure-borne sound sensors are sent to this small box which you see with the small green LED on the wall of the building here. So we are having an online information what is happening inside the mill and transfer that by a radio signal to a computer device system which is analyzing these sounds. Now, on chamber 1 and on chamber 2, we install these structure-borne sound sensors and have a very precise information about that, what is inside the mill happening. No crosstalk, no additional sound sources from outside can affect this structure-borne sound sensors. So we have no difficulty with another mill in the same building, etc., etc. Now, the third sensor is also unique because we measure the temperature inside the mill. Between chamber 1 and chamber 2, the diaphragm is free of balls, so there we can put inside a thermocouple, and this thermocouple gives us the exit temperature of chamber 1. Very interesting. We can avoid here by controlling this temperature that moisture in form of water comes from chamber 1 into chamber 2 and other features. Now, of course, you can show all these information, fill level plus temperature on your SCADA system, and more than 900 customers globally are doing so. However, most of these customers, if it is Lafarge-Holcim, if it is Heidelberg Cement or Votorantim, they are using our signals also in their own expert systems. However, if you have not an expert system in your group, we provide smart control. And this is what we do since more than 20 years. We programmed a specific software which is optimizing not only ball mills, but also vertical roller mills, raw mill mixture, and kilns. We are using modules of artificial intelligence. We are using smart control in the software, MPC, model predictive control, nonlinear model predictive control, and fuzzy logics. On a long-term analysis and short-term control, the target is to make the process smooth. And to make this process smooth, we need fast information. And that's why we also designed and developed SmartFill. You see that fill level number 1 and fill level number 2 are set points for this specific cement type, which is actually here produced. And we can say for each of these cement types, we have individually set points of fill level, we have individually working points, and whenever you change to another cement type, also the limits can be adjusted, and of course the fineness for the specific cement. Now again, specific on the type of cement which you actually produce, there is a balance between chamber 1 and chamber 2. And this balance can be changed immediately and dramatically when you change the type of cement. So Millmaster knows then he must move with fresh feed and with separator adjustment to this new adjustment of chamber 1 and chamber 2. Some case studies. YTL in Malaysia was latest installed completely on mill 5 and 6 with Millmaster, and we reached out with full autonomous operation in these mills. Autonomous means that the operator is nearly doing nothing anymore, 12% production increase. How was that possible? We have reached on specific mills here a smoothened process where the manual operation was more constant input. Now the Millmaster is adjusting the input and immediately we reach a much higher level, and this was also certified in performance letters. We have more reference and letters on demand. Very quick only, Spenner Cement in Berlin last year has reached with 30 different types of cement production, a much smoother production. We have Saurashtra Cement, Mita Group in India, where we have reached on mill number 1, again, autonomous operation and 12% production increase. Eastern Province Cement in Saudi Arabia, 9.8% production increase, and Al Safwa Cement, which was already a former Lafarge plant providing Lucy expert system. We have still improved here 4%, and the next Millmasters was already ordered. A huge list of commissionings of Millmaster is our reference in the pandemic. Without visiting these plants, just with remote commissioning, we have established all these projects, 5 in Australia, 3 in Saudi Arabia, etc., etc. Now, talking about the optimization potential, we have to consider, of course, a certain return of invest, your benefit. And this benefit can be easily calculated here as an example on a 130 tons per hour mill operating 7,200 hours in a year. Now we dropped the electrical power consumption, the relative power consumption, by 5%. This is when you get, of course, also production increase. You can convert it, of course, also in relative power consumption. So this is per year 3 million kilowatt hours. Hell of energy and money when you consider 10 US dollar cent per kilowatt hour. We speak about 304,000 US dollar savings per year, so a return of invest of less than 3 months. We usually calculate a price for the entire system, SmartFill Millmaster, plus commissioning of roughly 100,000 euros or dollars. Now, the Millmaster for vertical roller mill has shown even other fundamental success. In this plant of Equim in France, we operate from Friday afternoon to Monday morning, 72 hours, this mill complete autonomous. That means the plant is unmanned. This is possible today with artificial intelligence and process guidance systems like our Millmaster. Now, not only Millmaster, but also KilnMaster is in our product portfolio. And for KilnMaster, we need, of course, other type of sensors. Also here, we have designed a new revolutionary product, which is the gas temp flow. The gas temp flow is a precise and reliable acoustic measurement for flow and temperature. It can be installed on the downcomer to measure flow plus temperature, calciner exit, tertiary air, flow plus temperature, flue gas stack, bypass, secondary air, but also at the end of vertical roller mills. The advantage? It is complete contactless. There is no probe, there is no antenna, there's nothing what you put inside this gas stream. So we are absolute unsensitive in view of high temperatures and also unsensitive in view of dust. Changing dust conditions, high dust loads, it does not make any problem. So the downcomer application is very specific. Here in Heidelberg Cement, we have installed the first system. It is in the plant of Enningerloh. And you see here the graphs as a demo plot 72 hours, but I would like to show you again the benefit. The benefit computation comes from that point that we can take 8% air out of the system. How can that be? Today in your downcomer, you measure usually with delta P. And delta P, or also pitot tube measurements, have a failure of 10% from the technical measurement principle. So we have a failure with gas temp flow of 1% only. So if you operate on the safe side, which is mandatory in cement plants, you always consider your failure, so you add 10%. Now you can take 8% out, and these are phenomenal 500,000 cubic meters of air. 500,000 cubic meters of air with a 2 megawatt ID fan have a consumption, a power consumption, which we can reduce by 1.2 million kilowatt hours. Again, converted into savings, we speak about $128,000 per year, so a return of invest of less than 2 months. The system price of a gas temp flow 600 is approximately $30,000 US. Gas temp flow can be also installed on tertiary air, and all gas temps are used to make a sufficient control in kilns. Finally, I would like to introduce the kiln cooler system. The kiln cooler system is a system that sprays a water mist instead of air blowers on the kiln shell to cool the same. Now, air fans are highly power consuming, very noisy and limited in effect, so that we can here use a system alongside the kiln as a stationary device or a mobile device like this one, which you move alongside the kiln. And you see here that the system can be moved left and right. Now, these mechanical effects which the system provides are very simple. If you have a coating drop, you heat up the bricks, you heat up the steel expands. In this moment, the bricks become loose and are not fixed anymore. To fix them, we cool this section only, not the entire circumference, but this section of the kiln only, and bring it back to the same temperature like the other part and portion of the circumference. This stabilizes the bricks, new coating can rise. Most interesting, this is close to kiln tires, where you have this tight belt effect and this insulation. So it's necessary to cool just the kiln shell and not the ring itself. This is very easy to do with this water spray system, so that the kiln can shrink and the tire remains where it is. Plenty of references can be shown, plenty of reference letters show really the success of this system. And not only this mobile device, which you see here, which is cooling 2.5 meters, also the stationary device, which cools the entire kiln length, gives huge optimization potentials. And not only in saving the power, also in saving brick mechanical tensioning. Now, the bricks can be, not the bricks, we add additional to our IR sensor, the infrared sensor, in future a distance sensor, so that we can measure online the ovality of the system and permanent. So when we have the ovality, we have also the theoretical and practical axis of the kiln, so the alignment, so that we can, with an algorithm, spray and shrink just one side of the kiln to keep this alignment, this axis in the center. My friends will smile already and wait for that, what I always mention. We make a straight banana. We make the curved kiln straight again. And this fully online, and this is of course a revolutionary opportunity. But let me also say that just when you look for the savings of the electrical fans, which you switch off, you can save by water cooling 2.4 million kilowatt hours here in this example, just for 30 meters cooling. So a return of invest of 12 months is possible. A lot of certificate letters we have. Maybe one of the most impressive is that Vasiliko Cement in Cyprus says they reached a 98% substitution rate with alternative fuels in their plant only by using the kiln cooler, because now they can react very quick and fast on changing burning conditions. Yeah, 15 minutes are over. I hope that you can have enjoyed my presentation. More informations are to find on our web page. And I give now the word back to the highly amazing Cement Alliance team. Thank you very much for listening.